Hello everyone and welcome to our first episode on recursion. Now recursion is a process that's defined in terms of a smaller version of itself. Now I have to be honest with you, recursion does take a little while to understand and even longer to finally understand and recognize when it can be used in a process. So in order to simplify that, we're going to take a look at a few examples. If you want to learn Java programming or just programming in general, subscribe to this channel. We put out a lot of videos that range from beginner topics to more advanced programming concepts. Also, please like this video, share it with a friend, and write a comment as well. It goes a long way to help promote a channel like this. Now, let's get back to the video. The first example is we have a little character man. Now, we've used this character before in some of the previous videos, and we have 4 houses on a block. And what we want to do is we want to have 500 feet between each house, and we need directions to house number 4. So what would be your directions if this man would ask you, how do I get to house number 4? Well, the simplest directions would be, come onto our block, you'll be at house number 1, that's the very first house, walk 1,500 feet, and now you're at house number 4. But there's another way to do it. You could say, go to house number 3 and walk 500 feet. Then the man would say, but how do you get to house number 3? Oh, that's easy. Go to house number 2 and walk 500 feet. All right. Well, how do you get to house number 2? Oh, that's easy. Just go to house number 1 and walk 500 feet. Okay, but how do you get to house number 1? Oh, okay, so enter our street, and now you'll be at house number 1. Oh, okay, so now the man should know how to get to house number 4. Now that may seem like a complicated way of doing it, but that will illustrate the concept of recursion. Let's take a look at how we can do this with pseudocode. If we wrote a method, go to house n, n would be the number that you want to go to. So the first thing we're going to say is, if we're trying to get to house number 1, if n equals 1, then the directions are, enter the street, you're at house number 1. So basically you're done. But if n is not 1, what you want to do is you want to go to the house prior to whatever you're trying to get to, and then walk 500 feet. As you can see, we're defining go to house in terms of the prior house, or a smaller version of itself. If you want to get to house 3, first you got to get to house 2, and then you walk 500 feet. The walking 500 feet is something that's constant every single time. No matter which house you go to get to the next one, you have to walk 500 feet. Now this is called the initial condition. This is something that's going to stop the recursion from going on forever. At some point, no matter what house number you want to get to, if we keep going back, and saying, okay, get to the one before, then get to the one before, then get to the one before, eventually you'll be at house number 1. This is how the recursion ends, because here when n is 1, we don't go back another house and say, okay, recursion again. What we do is we say, oh, okay, just this is what you're going to do. This is the recursive condition. This says that if you want to go to any other house besides 1, you have to go to the one before it first and then walk 500 feet. So let's move this code over, give us a little bit more room, and let's take a look at an example as we step through it. So we're going to call this method go to house number 4. Well, what's the first thing that happens? So we go into this method, we pass in a 4, n is now 4, and then, well, we go to here because n is not 1, so we go to this else statement, which means we're going to go to house 4 minus 1. So that's 3. So we're going to go to house 3. So now we come into the method again with a new value for n. n is now 3. Well, what do we do now? Well, since n is 3, we're going to jump down to the else. And we're going to say, okay, well, before you go to house 3, you have to go to house 2. So we call the method again. So now n is 2. Again, we go to the else statement. The else statement says go to house 1. 2 minus 1 is 1. So we go in again. Now n is 1. But this time, we go to the if part. Because n is 1, we just say, oh, okay, enter our street and you will be at house 1. So that's what the man does, because we've just returned some directions. But then we're done with the purple version of go to house. So we're going to return out of the purple version to the red version, which is where we called it from, right here. So now we're done with go to house 1. Now we're going to walk 500 feet. Okay, so let's do that. That got us to house 2, but now we're done going to house number 2. So we jump back out of the red version of go to house, and we're back here. This is where we told it to go to house 2. So now that we're done with that, we're going to walk 500 feet. Okay, there we go. But then we're done with go to house 3, which means we back out and we go to wherever we called it from, which was right here. And then we walk 500 feet. And there we are. Then we back out and we are complete. That is an example of how we would use recursion. Let's take a look at another example, factorial. N factorial, in case you're not aware of the mathematical term of factorial, n factorial means n times n minus 1 times n minus 2 all the way down to 1. So for example, 4 factorial would be 4 times 3 times 2 times 1. 10 factorial would be 10 times 9 times 8 all the way down to 1. But notice that this is n minus 1 factorial, which makes this a perfect candidate for recursion. We can define n factorial as n times the prior number's factorial. So let's take a look at some code. This is the way it would look in Java. As you can see, we've declared a function, factorial. We pass in the value that we want to calculate. Now, the first line of code says, if n is 0, we just want to return 1. We can't go forever. So as soon as we get to 0, that's just 1. But if it's not 0, we're going to return n times the prior number's factorial. Let's step through this and see how it works. When we want to print factorial 3, the first thing we do is we call factorial where n is 3. So we're going to check to see, is 3 equal to 0? No. So we're going to jump down to the else. 3 times factorial 2. Okay, so factorial 2 means we have to call the method again. But this time n's 2. So of course we jump down to the else. 2 times factorial 1. Okay, so now we're going to call the method again, where n is 1. All right, so now we're going to do 1 times factorial 0. We call the method again, n is now 0. But this time we jump into the if statement. 0 equals 0, so we return 1. Okay, so we're returning 1 back to here. This is where we called the factorial method where n is 0. So this will take on the value of 1. But now we're ready to return from here. And 1 times 1 is still 1. So the value here is going to change to 1. But then we have a return statement here. 2 times 1 is 2. That value gets passed back into wherever we call this version of the method from, and this becomes 2. But now this return statement will go back to our original call to factorial. 3 times 2 is 6. So we print 6. So now we're going to head over to NetBeans and just write this code and make sure it works. Okay, so as you can see, I've created a class, myMath. This is where I'm going to put the factorial method. And I've created a recursion driver. Here's my standard main method. And from here, I'm going to call the factorial method. So first, let's just make the factorial method. So we'll public, it'll return an int. Okay, we have our parameter n. And all we're going to do is we're going to just check to see if n is equal to 0, then we're going to return 1, because 0 factorial is 1. Otherwise, it's going to be equal to, we're going to return n times, and then we're just going to say factorial of n minus 1. And that's really it for factorial. No loop, no nothing. The recursion handles the loop for you. Recursion driver. Let's create. And here we go. Let's just give it a shot. 4 factorial. 4 factorial is 24. 4 times 3 times 2 times 1. Let's run this. We should get an output of 24. There it is. Looks pretty good. Looks pretty good. So in conclusion, recursion is a little bit complicated. It will take you a while to get used to using it. But you know what they say. In order to understand recursion, you must first understand recursion. I hope you learned something from watching this video. Please remember to subscribe and share this video with others who are learning Java programming. Thanks for watching, and take care, everyone.